Hello, I'm Felix. I'm a freelance web developer here in Berlin. I think you can hear me like that as well. No. Sorry guys for the bumps. So, I have to use this laptop because it records audio. Webkeezy. Okay, so let's get started. Jan introduced me talking about recording. I choose to not talk about recording. Sorry. But we're gonna talk about more basic because it's called intro today, right? So I decided to talk about loading and playing stuff in WebAudio. How many of you already did that? Like loaded a sample and played it? Half? Okay, so it's not bad of me to do such a basic talk. And maybe you guys can still learn something from it, I don't know. Let's see. So Webkeezy is an app I built some time ago when this company, let's just start with that, Path. So Path is a cool company from the States. Built this cool tool called Keezy. It's an iOS app. How many of you guys know it? 1, 2. Okay, so it's this fun app where you can sample your voice, store samples, and then replay them. And I thought when they brought that out, it was kind of the starting time of WebAudio, I think 1.5 years ago. And I thought this is totally possible in the web. So I created a web version of it. And it's on felixniklas.com/Keezy. So this is a bigger version for laptops, and it works like this. At first you have to allow the microphone access, and then you can we make it a bit louder. So this is the recording part I wanted to talk about initially, but I choose to talk about a different part of it, and that is that you can also drop samples into it. And how, so I want to explain to you guys how to load the samples into WebAudio and then how to play them. So it works like this. I have it in there as well. Yeah. So the WebAudio context, that's like where everything is going on, and this is like its own playground, kind of. And it always contains a destination, which is the speakers. And so how do we recreate it? By creating a new WebAudio context. Before we can do that, we have to check the browser support and see that while there's always this bad child, there's still some browsers which need some prefixes for it. So first we have to normalize the WebAudio context, check if they don't have the audio context but the WebKit audio context in some browsers, and then we can go on and create it. If it's Internet Explorer, it will fail, so we should catch that. And then we can start the fun. And that is connecting a source to the destination. And the WebAudio context is a bit weird for you as a JavaScript developer because it doesn't work as you would think it would. When you start this buffer source, when you connect it, you would think that every time you connect it once, and then you play it, and you play it again, and you play it again, and then you stop it or play it and stop it and stuff like that. But buffer source is rather a thing where you create it once, and then it's gone. So you have to create it every time again. And this is, I think, because it's they intended, or I think they based it a lot on the native audio API. where you need that kind of stuff, that kind of control for games, where you can say, I have this sound, but not right now, but it shouldn't play right now, but like in 5 seconds, but precisely in 5 seconds. So therefore you create these buffer sources and then and you have to create new ones. So so it works like this. You have the context from before. We create a buffer source. Then we connect this buffer source, as we saw visually, to the destination. Then we add a buffer, which is like the audio data. And then we tell it to start right ahead in this case. We could also add a number there in seconds, like it should start in 2 seconds or something like that. Yeah. So where do we get this buffer from? For example, from a WAV file. So how does it work? In Webkeezy, I use drag and drop to get the files into it. So we need the file reader to read the data from the file. Then we have to decode the audio data. Then we have to store the buffer, because we will have to use it again and again. We have to create a new buffer source, put the buffer in, play it. Create a new one whenever we want to replay the sound. So this would be the function we would bind to the drop event, or the drop listener. So we access the data, the file. We check if it's of the type audio wave, otherwise we would get an error. Then we start our file reader, add our listener so that when it's loaded, because this will happen asynchronously, it should decode it. And then we read it in as an array buffer, the file. And what's happening in here then, after it's, so like it will go from here to, this will happen first, and then when it's done, it will go to this function. And then we'll take the target results and call this function when it was when it worked, and the other function if there was an error reading it. And there we will get the buffer out of it. So the decode audio data is a audio context function once again, or method. So how does the store buffer function look like? This would be it. Yeah. However you want to store the buffer, and then you can play it, and then you can play it all the time, as often as you want, by calling this play function, where we use this newly loaded buffer. So let's see how this works. Oh damn it! Do you have samples on it? I forgot about that. Yay! Conga, sounds great.
You can drag and drop from there.
From here? Without showing embarrassing download stuff?
Okay. Yeah.
Oh, doesn't work.
Show some embarrassing download stuff.
Wait, let's reload, maybe.
That's okay.
Okay. Wait, let's go away from that. No, sorry. Here. Drop it like it's up. And there we have it. The low conga, and now play it. Nice. So, yeah, that was that. Yeah. Questions so far? Excuse me? No.
Can you create a beat from the sample website? No.
Download more stuff. Yeah, probably. But we need a hi-hat at least. Then we need a bass.
On the side there was
There was, okay, oh nice, a kick, great. Boom kick. Then a hi-hat. Oh, where is it? How do you sort this stuff?
No idea.
Pedal.
Please don't search.
Okay, that was a bit bad placed. Yeah, I mean we can add some more harmonics to it. Oh wait. Well, next up would be a sampler to sequencer to sequence that stuff. Yeah. All right, that's it.
Yeah, about this buffer reconnecting, I always was wondering how much does this affect performance. So, I mean, usually I would not do this because I think there's much of like reconfiguring going on behind the scenes. So, but we have to reconnect, you know. So, do you know how much of performance or other consequences is?
So as far as I understood it from
Can you
the,
repeat?
so the point or your question is how much performance this buffer reconnect or this creating a buffer source and then connecting it and playing it,
Right.
doing how much performance that costs. Like it seems like an overhead. Or yeah. So as far as I understood that from the beginning of the WebAudio, like there was a lot of discussion about it. And Mozilla brought out like the first version of the draft, and I think it might as well be that they didn't have that in there. But then Google, some guys from Google, I think one guy in particular, I forgot his name. Chris Wilson took over, but there was somebody before him. I think he was also called Chris something, who wrote the most part, like the biggest part of the standard. Chris Wilson did now the MIDI part mostly, and is took over. Yeah. But as far as I understood it, they decided to go away from the Mozilla part because that would have been way more processor intensive, because they wanted to have way more access to the stuff. And Google, or the Google guy, Chris something, decided to go rather in a more abstracted but performance-wise better way of doing it by. So you can still access the raw audio data with a processing node or something, process node where you get all this stuff. But they tried to abstract the basic things away so that they are much more performant. But this particular case of creating new sources, I think that was mostly out of having a lot of control over timing, because usually when you do audio like a machine gun sound where you have maybe lots of different sounds playing you usually plan that in advance, create these notes in advance and time them in advance. And I think that is eventually for the precise play time, to have them play at the exact right time. I think this approach they took is more for that case. So it is more for games, I think, how they made it. But I think it seems that it's also the most performant way of doing it. Or anybody else has an opinion on that? Or?
Does the new API have any advantages over any of the native implementations? Like anything which is new and more modern, which could be taken over to native?
I'm sorry, I don't have knowledge about the native audio, so I can't answer that.
But I think to better explain why you have to recreate the buffer source every time, I think it's because basically every single audio audio buffer, audio sample is unique in when it will exactly be scheduled on the audio device. Even if it's the same sound, you have to create a new buffer because it is in fact going to be a new sample that's going to be processed completely separately of the other one that you might have scheduled before, because that's just another sample. Does that make sense?
Yeah.
It's even if you mix that with others,
there's no general bus or track you can mix it.
Well, you can.
It's just everything goes on its own time.
Yeah, exactly. I mean, in the end, they get
because
mixed
of
together,
timing.
of course.
It's not necessarily garbage collection, but because you can precisely time stuff. We're probably going to have a talk about that soon because sequencing is quite tricky with the WebAudio API. But I think that power to hook the things in before the time is there and then have them play instantly at the precise time. I think this is the main reason why they.
Yeah, that's
But it's all a bit of speculation.
Yeah, but then you would say you would just keep it and you would re-trigger it or something or play it on that.
No, you created a thing that is exactly played at this time. So when you play it again, it will play it in the past. Nobody will.
I mean, you don't create a big thing. The big thing is the buffer.
Yeah.
And you have it stored, and you only create like a hook into the timeline.
Yeah.
That's like what the buffer source is. So it is not big. It is not like something big that has to be collected or something. It's only, yeah.
Well, also you can like change a buffer in the processing pipeline without copying it. You can just modify it, and it might be a buffer that is still being processed somewhere in the pipeline. If you want to re-trigger, if you would re-trigger the same one, like what kind of behavior is that supposed to make, right? You have to kind of, even if it's the same sound, input new data, that as new data into the pipeline. Because there's like a no copy strategy.
I think you have to visualize that. I understand.
It's kind of, yeah.
Your thoughts, but next talk.
And maybe it makes sense to you. Yeah,
Yeah,
okay,
yeah.
cool.
There's definitely questions about that. Okay, I hand back to the.
Thanks, Felix.